Okay, today we are going to discuss the chapter 3, and the topic of the chapter 3 is water and the wastewater treatment. We are going to discuss how can we treat the wastewater, and we will discuss the different methods like biological, chemical, and physical. So, in previous classes, we have already discussed these two chapters. Number one is Introduction to Environmental Engineering, and the second one is the Environmental Chemistry. But today, in today's class, we will cover the Unit 3, which is Water and Wastewater Treatment. These are the main subtopics of this module: the principle of wastewater and the physical, chemical, and biological treatment processes. And the third one is the wastewater collection and the treatment systems. So, first of all, wastewater. So, why there is need to treat the wastewater? So, as you know that the wastewater contain a number of the organic matter and a number of the nutrients itself in it. So basically, the worldwide, the majority of the wastewater is neither collected nor treated. Wastewater is a valuable resources, but it is often seen as a burden to be disposed of. And this perception must needs to be changed because the wastewater contain a number of the hazardous chemical and a number of the hazardous microbes in it. And whenever we discarded that water into the system, into the environment, without the treatment of that particular wastewater, it creates the uh, diseases and it creates the uh, harmful impact on the society, on the environment, and on the health of the human beings. So basically, where does the wastewater comes from? So the wastewater comes from the homes, the cities, and the industries. Basically, the wastewater basically comes from the different industries. For instance, leather industry, textile industry, pharmaceutical industries. So it contain a number of the byproducts in it which are very dangerous and which must need to be biodegraded and must need to be treated before entering into the food chain or entering into the environment. So the thing is, 80% of the global wastewater is released to the environment without the adequate treatments. So this approach must needs to be changed. We have to be very concerned about the treatments of the water, and we have to be very careful about the recovery of the organic matter and the recoveries of the useful products from the wastewater, which can be reused or the recycled so that we can save our valuable assets. So the next thing is, why do we need to treat the wastewater? The wastewater treatment is important to remove the constituents like contaminants that could harm the people or the environment, and their main harmful constituents includes the organic solids, nutrients, and the pathogens. So here you can recycle the organic solids and the nutrients as well, but you can treat the pathogen. So the next thing is water treatment. There are some typical standards, so we have to be measure these standards into the wastewater so that we can treat that water. For instance, the sewage released by the residents, business industries, and it can contain both liquid and solid components. So it depends upon the type of the wastewater, that which industry or the which type of the wastewater has been released by the industry, so that we can recover that particular or we can recycle that particular liquid or that particular element from the that particular wastewater. For instance, if there is a industry of the metallurgy, so a number of the beneficial and precious metals, you can say that you can recover from that wastewater. And whenever you are going to treat any wastewater, you must know its biological oxygen demand, and you must measure the typical amount of the microorganisms which are present in it, so that it will be very clear to you that this wastewater must need to be treated. For instance, the biological oxygen demand BOD5, is basically the measure of the amount of the oxygen microbes used in a 5-day breakdown of the cells. So you have to note the biological oxygen demands. You can just put the electrode into the wastewater and it will give you the biological oxygen demand. So the next thing is you can count the coliform bacteria such as E. coli, which is basically used as an indicator of disease causing the organism that are present in sewage or any wastewater. So you have, when you calculate the biological oxygen demand and when you calculate the microorganism including coliform bacteria, so that coliform bacteria count and the biological demand, if increases from this limit, then the water must be treated. And this sewage water also high in the concentration of the ammonia, phosphorus, minerals, and metals. So here you can take the example of the phosphorus. If you become the successful in recovering the phosphorus, so you can use that phosphorus as a fertilizer in the soil for cultivation of the crops as well. So again, when you are going to treat the wastewater, you must have a very clear idea about the certain permissible limits, certain rules and regulation which must to be met. For instance, the wastewater treatment releases to the river system is governed by the state as dictated by the Clean Water Act. So, if you are an environmental engineer in any industry, you must have a very clear idea about the permissible limits and about the discharge permit of that particular industry, of that particular working area. So, that permits and that permissible limits issued by the government. For example, you are working in Qatar or you are working in the Saudi, and you are working in UAE. So that entirely depend upon the government of that country, that which type of the standards and which rules and regulation they are imposing on the industries and they are imposing on the public. So that must be under consideration when you are going to release that wastewater. Second is the discharge permits are issued to the facility and have the specific requirement depending on the locations. So ideally, it is very ideally that you are not going to install any kind of industries in a residential area, because the residents and the local people will be affected from the smoke, from the discharge of that wastewater. So if it was preferably that it was preferably by the engineers, that by the environmental impact assessments and the environmentalist who gave the idea to install the industries in any area, there will be not any kind of the residential people, or there are not any kind of the local peoples who are living in that nearby areas. So it depend upon the location, that at to which extent you have to treat your wastewater. So basically, the local health department regulates the small septic system serving 1 to 3 families. This is basically when you have to obey from the higher authorities. Like, for example, if you are obeying the rules which are issued by the government, then you have to follow the rules which have been issued by the local government or the district level. So you have to fulfill all these type of the rules and regulations before treating that, typically wastewater. Okay, so the wastewater is all the water we use that goes down the drain. So here is the question for you guys. Does all the wastewater needs to be treated? Yes, please. Anyone? This is a question to you guys. Can you please tell me? Does all the wastewater needs to be treated or not?
Not
Yes, Pap. Yes, Pap.
Yes. There is a need to treat the all the wastewater. And Second question is, where does this makes you wonder about how you could reuse some of the wastewater in your home? So if the water has been recycled, so in which activities you people can reuse? Can you please tell me?
For agriculture
Yes, for agriculture purposes and
and for dust control, any type of water.
yes, for dust control, like you can use that water on the roads, and you can use that water in cultivation of the ornamental plants as well. So first question, the answer of the first question is yes. We need to treat all the wastewater which has been generated in the which has been generated by any industry or by any you can say that by any municipal area. And the second is yes, you can use that water to in other activities like washing purposes or for irrigation purposes. So the next thing is, so there are the three main processes through which you can treat the wastewater. Number one is the physical, second is the chemical, and third one is the biological. So in physical methods, you can have these four options. For instance, you can go for the flocculation, flotation, filtration, and the sedimentation. You can learn these method like you have the F cube and S, like flocculation, flotation, filtration, and sedimentation. In chemical processes, you have the precipitation, adsorption, and disinfection. And in biological treatment strategies, you have aerobic, anaerobic, and anoxic. So I'm going to discuss all these methods in the next slides. So this is just an overview that you must have an idea about what type of the method you can use in treating the wastewater. Okay, so before in discussing that treatment, there is a general stage. You can say that there is a general stage in which water has been passed uh, before re-entering into the environment. So first is the preliminary treatment. So basically, in preliminary treatment, the screens are used which can remove the debris and which can remove the grit and the pebbles, etc. So basically, in preliminary method, what you can do basically, it is the first step in the wastewater treatment processes, and this treatment involves the mechanical removal of both the fine and the dirt and the solid particles. And the waste water passes through a screen mechanism that traps a piece of the wood and the plastic particles and the wires and the pebbles which are present in the wastewater. So the percentage can also be higher depending on the intended the use of the final product. So that is you can see that that is entirely depend on the intentions, that after treatment that water is go for either for the washing purposes or other either for the agriculture purposes. So your objective basically defines the extent of treatment. And basically in that case of drinking water, for instance, the preliminary stages may remove more than 80% of the solid material, leaving very few materials to be removed in the subsequent stages. Like you have done your duty at the first stage, and the remaining are just for the refining purposes. So basically, once the material are removed, they are either buried or burned, and you can bury it in the landfill. Landfills are the another basically um, is a body in under the ground, and which has been constructed very systematically with the help of the sheet so that it does not enter into the environment again. Okay, however, even burning is not environmental friendly practice, but since it allows the chemical and the non-decomposing materials such as plastics to pollute the soil, so basically the quantity of the solid material extracted from the wastewater usually determine the most appropriate disposable method. So you can use the various mechanisms that can ensure the safe burning of the plastic material to minimize the potential environmental damages. Understand? So basically, the preliminary treatment is basically the removal of the light debris with the help of the screens, and it is the initial step in the wastewater treatment. So the second one is the primary treatment. So in primary treatment is basically the second stage of the wastewater treatment, and you can say that primary treatment allows the wastewater or the effluent to slowly pass through a grid tanks, allowing the fine sand particles to settle down. So I'm going to show you that diagram. Yeah, this is the diagram. Is it visible to you guys?
Yes, ma'am.
Yes, you can see
Yes,
that
ma'am.
the wastewater and there here is the screen, and this is the preliminary, the debris screen. This is the preliminary basically the step, and this is the primary basically the primary treatment, and then we have the secondary treatment, and then we have the tertiary treatment. So when we have read the theory after that, this diagram will really help you guys. So in the primary treatment, the basically it is the second stage, and it is basically the passing of the wastewater through the grid tanks. So basically there are these certain tanks which I will show you in the next slides, in which are the real type of the wastewater treatment, wastewater plant which has been already installed in the industries. So you will have a very clear idea about it. So basically, it is still possible to have finer sand particles suspended in the wastewater even after passing through the preliminary stages. The primary treatment can even remove these finer particles, and the wastewater is then allowed to pass into a large primary sedimentation tanks, where most of the solid particles settles out to form the sludge. And basically, the primary treatment removed about 60 to 70% of the suspended solid material. And that the remaining liquid basically after the primary sedimentation usually contain a very fine solid particles in the form of the dissolved matter, which can be further removed in the secondary stage. So in the secondary treatment, you can see that there is aeration tank in which another tank in which air has been passed, and through the aeration the microorganism decompose the organic matter in it. So basically in the secondary treatment, which is basically designed to remove the 70 to 90% of the suspended solid material in the wastewater, and the secondary treatment is basically a biological process in which because you are using the microbes, so that microbes will help to decompose the organic compounds and the contaminants which are toxic for the environment. And basically the aerobic means those bacteria which can use oxygen to break down of that particular contaminant. Where there is the word is aerobic aeration, you guys will have a clear idea about it, that all right, it is the involvement of the air in it, the involvement of the air, the involvement of the oxygen. So basically, the aerobic bacteria uses the that air, that oxygen to degrade, to decompose that particular contaminant. So two processes you can use during the secondary treatment to remove the dissolved material. So basically, the two processes includes the filter beds and the activated sludge. The filter beds are basically where the wastewater is separated slowly over the beds of the broken stones at the gravel to increase the surface area needed for the speedy oxidation process. So what is happening in this secondary treatment? You are spraying that water on the beds of the rocks so that they have the maximum surface area for the oxidation, so that the bacteria will perform very well when they have the adequate amount of the oxygen. And the wastewater secondary sedimentation is basically again the active. So the sludge has been activated because that sludge contain the microorganisms that are needed for the breakdown of that contaminant, and they can digest all the suspended organic matter into the wastewater. So basically, you can use the secondary clarifiers, which is basically biological solid settles out. So this is not the a journal settling which we have done in the preliminary, the primary treatment. So the next is the tertiary treatment, and it involves the removing of the remaining solids, and it basically kills the pathogen, and it can remove the nitrogen and phosphorus, so you can recycle that nitrogen and phosphorus. So basically in tertiary treatment, which is basically designed to remove the toxic compounds, including phosphorus and nitrogen compounds, that cannot be removed during the primary and the secondary treatment. So the organic contaminants are that compounds which has been not treated with the preliminary, primary, and the secondary treatments. That tertiary treatment will completely solve that issue. That tertiary treatment is successful in removing 20 to 40% of the toxic material which are present in that particular wastewater treatment. So the tertiary treatment involves the use of the various tools. For example, ultraviolet lights, filtration membranes, and the other forms of the disinfectants. So, what is the purpose of the tertiary treatments? So, here is the question that what is the main purpose of the another treatment which is known as the tertiary treatment? So, basically, the main purpose of the tertiary treatment is to ensure that the final product does not contain any toxic compound that can be harmful to the human beings or the plants. Is it clear to you?
Yes, ma'am.
Yeah, so you know that the final step is basically the product also undergoes through screening to ensure that it is free from any chemical or the potential harmful compounds. Various cities around the world basically rely on the treated wastewater to boost the supply of the clean and the safe water for the drinking. And keeping the final product free from the chemical is one of the topmost considerations before applying any clean water to the consumer. So, if the objective is to reuse that water for the drinking purposes, so you have to be very conscious about the tertiary treatment. And again, which is the production of the sludge, because the sludge has been activated in this country stages. So you can say that the thickening of the sludge is basically the first step, which is basically reducing the sludge volume, and it can be digested anaerobically. Anaerobically means here is the use of the microorganism which does not need any kind of the oxygen. They can perform in the absence of the oxygen, and that microorganisms, that bacteria basically break down the organic matter. And again, the next step is the dewatering. It removes the water from the sludge. And the last step is the disposal or the reuse. It is basically safely disposes or reuses that treated sludge, and which is basically reused for the agriculture purposes. It is one of the topmost purpose of the reuse of the sludge. So this is again is a flow sheet. So you people have now have a clear idea about the what is preliminary stage in which the wastewater from the sewage undergoes for this screening, and then the primary, the wastewater undergoes for the sedimentation in the sedimentation tanks, and the third one is secondary in which the biological processes. Basically, in this process, we are going to use the microorganism, and the last step is the tertiary method in which the nutrient stripping using the filter beds are the activated sludge followed by the effluent discharge. So this is again that stages. So I have made this flow chart so that you can get a clear idea that primary treatment, biological treatment, and after biological, this is basically the secondary clarifiers, and then the nutrient removal, and then the final liquid has been passed to the further usage. So this is very interesting diagram. So you can have a very clear idea. The first is the debris cleaning, and the second step is the grit removal, and that is done in the preliminary stages. And then the primary, basically after the grit removal, the primary clarification is has been done in this tank, and the sludge digesters have been used, and from the sludge that is transported to the further usage, like for any other use you can do, for like for instance you can do it for the agriculture purposes, and you can bury that sludge into the landfill. That depend upon your objective, what you can do with that sludge. And in the secondary uh, treatment, again here is the aeration tank. The air has been introduced into the aeration tank, and the microbes act on that wastewater, and they can degrade it, or they can decompose the toxic compound into the simpler one, so that will be a no harm for the environment. And again, that is the secondary clarification tank. And again, here is the production of the sludge. You can see that again, here is the production of the sludge in both primary and the secondary clarification tanks. That sludge directly enter into the sludge digesters. Again, here is the filter sheet and the disinfection chamber, in which you can use the chlorine or the ultraviolet radiations for further treatment of the water, and then the effluent has been appeared, and you can discharge that into the surface water, and that it is safely discharge that wastewater into the environment after this particular treatment of the wastewater. So then you can say that there is no harm in releasing that wastewater in any water body or in any area, so that the public will also be safe by using that particular treatment. So next is wastewater treatment processes. So basically we have the three wastewater treatment process, including physical, chemical, and biological. So basically, the physical treatment include the focus on the separating the large solids by utilizing the screens or the filters. So physically means you are using the physical methods. For instance, you are using the screens and the filters. But in chemical treatments, as the name represents, that the chemical reactions is basically aids in converting the contaminants into the precipitated solids that can be separated from the wastewater. So it is basically denoted by the name as well, that you can introduce certain types of the chemicals in the wastewater that can convert the contaminants, that particular contaminant, into the precipitated solids form. So you can remove that contaminant by using any kind of the sieves or the membranes. So here I want to say that what type of chemical you want to use, that depend on the contaminant which is present in the wastewater. Because when the wastewater has been generated by the textile industry, the pharmaceutical industry, then you are not going to use the same chemical in the both type of the wastewater which has been released from the textile and the pharmaceutical industries, because the wastewater has different types of the toxic elements in it. So that depend according to your type of the wastewater. So you can use that particular chemical for the treatments. The biological treatments means the use of the microorganism. The use of the bacteria is involved in the biological treatment, and that microorganism is basically break down and stabilize the organic matter present into the wastewater. So it is very easy to remember when you memorize the method, like for example, physical, chemical, and biological. It's very easy for you guys to learn this. Again, the last step, which is advanced treatment, it includes the nanomembranes like membrane filtration, disinfection, use the chlorine or the ultraviolet radiations, and the next is the activated carbon adsorption, and the last one is the advanced oxidation. I will discuss all these advanced methods in the next slides, so please don't worry. So yeah, before starting that particular physical and biological and chemical treatments, can anybody tell me about the what we have learned in this class until now? Can you give me a recap of 2 to 3 minutes?
That all wastewater has to be treated. And we have also discussed the water treatment from preliminary, primary, secondary, tertiary, ma'am.
Yes, we have discussed the four stages of the wastewater treatment. Number one is the preliminary, and second one is, yes, Rosanto, please tell me.
Primary,
Second,
primary, ma'am. Primary,
primary. Yes,
then secondary and tertiary, ma'am.
yes. And uh, can I ask one question, that which treatment stage is used to adopt for when you are going to produce the drinking water, when you are going to recover the maximum nutrients and you release that water for the drinking purposes? Yeah, which stage is very important for it? Yeah, this is tertiary treatment. The tertiary stage is very important when the end product is the drinking water. And again, it depends upon the objective, what type, um, what the end product will be used for. That depend upon the your objectives. So I'm going to discuss all the treatments, including physical, chemical, and biological. So first one, in physical treatment processes, the first step is the screening. It is basically removing the large debris, for example, leaves, twigs, rubbish, using the screen or the grids. And the second step is the sedimentation. It is basically the allowing the suspended solid to settle at the bottom of a tank due to the gravity. And we have already seen that diagram, so you people have a clear idea about the sedimentation. And the third step is the filtration, which is basically passing the water through the filters, like, and you can remove the 100%, yeah, 80 to 100% sand, gravel, and the charcoal to remove the small particles. Even you can remove the small particles with the help of that filtration. The next step is the aeration. It is basically introducing the air into the water to remove the dissolved gases and oxidize the metal. The next is the introducing the air into the water, removing the dissolved gases. So when you are introducing the air, that basically remove the dissolved gases. So aeration is a very important step that can even remove the dissolved toxic gases, including carbon dioxide, and that air can oxidize the dissolved metal, for example, iron and manganese. And the fifth step is the precipitation. It is the introduction of the chemical into the particular wastewater, and that chemical will form the precipitates of that contaminants, and you can again use any kind of the sieves and recover them and that contaminant, and you can use that wastewater, and you can reuse it and recycle that wastewater. Next one is the chemical treatment process. It includes the coagulation and flocculation. It you can add the coagulants, which are easily available in the market, to neutralize the particles and form the flocks for the easier removal. And the second step in the chemical treatment process is the disinfection. It is basically addition of the chemicals like chlorine or the ozone, which can be used to kill the pathogen. Okay, the third step, which is the very important step, which is the pH adjustment. Usually, when the water has been generated the after such type of the processing in any kind of industry, then the pH becomes the acid or basic. So usually the acidic pH of the wastewater has been noted until now in the laboratories. So you can add the chemicals to adjust the pH, and you can adjust the level of the water to make it neutral or slightly alkaline. Okay, the next step is the biological treatment processes. It includes the activated sludge process. In activated sludge process, you are going to use the aerated tanks, and where the microorganism decompose the organic matter into the wastewater. For example, bacteria. I have already discussed that the anaerobic bacteria, here we can use that anaerobic bacteria. And the second main step is the trickling filters, passing the wastewater over the bed of the media where the microorganisms break down the organic matter. Trickling filters is basically that the amount of the water goes very slowly over these type of the beds, so that the maximum amount of the organic matter can be break down by the bacteria. So the trickling filters is a very effective strategy to remove the contaminants, to remove the toxic matter into the wastewater. The third one is the lagoon and constructed wetlands. Using the natural or the artificial ponds and the wetlands where the microorganism and the plants treat the wastewater. So it is basically the involvement of the bioremediation and the phytoremediation. You can use the organism like fungi and the bacteria and the algae as well. Algae that can form the algal blooms. So you can use these three microorganisms, and the plants is basically such plants you can use in that particular strategy, like that are phyto extracted, or they can extract maximum amount of the organic matter from the water, or from the toxic from the toxic matter, like you can say that chromium, lead, and the cadmium. So these plants basically uptake that particular heavy metal. So here I want to mention that you can't cultivate the vegetables or fruit in this phytoremediation technique. You have to be very clear about it, because that again that toxic metal re-enter into the food chain. So you have to pick the any species. For example, you can pick the ornamental plants, because that can only use for the decoration purposes. So there is a very effective use to treat the wastewater, so that can, because the ornamental plants has been successful in generating the revenue, so it will be very good for any economic condition of any country. So different countries are currently adopting these methods, like they can playing the dual role by treating the wastewater, and they can import that ornamental plants, or they can use that ornamental plants for generating the revenue. So here I have completed the three main basic treatment processes, including physical, chemical, and biological treatment processes. So this is very clear to you, because the microorganisms and the plants both are the living organisms. So that category is very important in this biological treatment processes. So here is the very important and the unique and updated form and updated process which can be used in treating the wastewater treatment. It is basically the advanced oxygen processes. AOP is basically the currently at the search spotlight for the wastewater treatment, and everyone is now interested in adopting the advanced oxidation process. So here is the question I will ask from you guys, that what is the advanced oxidation process? So first of all, I will give you an idea, and after that, I will ask from you people that what you uh, get the understanding about the advanced oxygen processes. So it is basically a process in which reactive oxygen species formed, and that reactive oxygen species are basically the radicals of oxygen or the hydroxyl groups. That radical means they have the unpaired of the electron, and they are very reactive, and they can react on that contaminant and oxidize that contaminant, and they can convert it that toxic contaminant into the simpler one. For example, the physical adsorption is the requirement for the advanced oxygen process. So, physical adsorption is basically a process in which you can use any kind of membrane in primary, secondary, or tertiary stages, and that membrane basically has certain kind of coating in it, in which that screen that reactive oxygen species formed whenever they contact with the wastewater treatment. And when the water pass from that screen, that reactive oxygen species attack on that contaminants, and you can find a very clean water on the other side of the membrane. So basically, the physical adsorption is a requirement for the advanced oxidation process, and which enables the oxidation of the contaminants on the surface of the catalyst. So here is a term which is known as catalyst. So anybody have an idea what is catalyst? Yes. What is catalyst? Anybody have any idea what is meant by the term catalyst? Okay, I will tell you. A catalyst is basically any any element or anything which can speed up the reaction. Catalyst mean to accelerate, to elevate the treatment processes. So you are using the catalyst in advanced oxidation process, because in this kind of the wastewater treatments are very laborious, and it's very time taking. So the catalyst is basically used in this advanced oxidation process so that it can speed up the reaction, that saves the time, because every day a huge number of the liters, or a huge number of the gallons are produces from any industry. So there is a need to speed up that process. So basically, in the introduction of the adsorption sheets and the introduction of the catalyst, there is a blend of the physical and the chemical processes that appear to be very effective in treating the wastewater treatment, and that appears to be an attractive wastewater treatment solution, especially when you are going to treat the organic contaminants. Organic contaminants includes the contaminants of any pharmaceutical industries. All right. So the advanced oxidation process is one of the top of the method which you can use in this advanced technological world. So the I have mentioned that in advanced oxygen processes, the oxygen reactive species have been produced. So that is basically the hydroxyl ion. Hydroxyl ion means OH negative. So that hydroxyl ion, why we are so much interested in producing that hydroxyl ion? So can anybody tell me about it, that why we are so interested in the formation of the hydroxyl ion in the advanced oxidation process? Yes, you people, please tell me. Yes, anyone? Okay, I will tell you that hydroxyl radical is a very powerful oxidant. It is basically have the ability to oxidize that contaminant, and that hydroxyl radical has the ability to control the rate of the reaction, and it is highly reactive. It does not require any initial energy. Whenever the hydroxyl radical produced, then you don't have to do the extra effort. You know that reaction will be a spontaneous reaction, that it will be once it will begin, so it will continuously that hydroxyl radical will react upon that contaminant. And the third, it is very easily generated. So you just have to use that um, aeration method, or you can use the certain type of the codings. For example, you can paste the activated carbon on that sheet. So after the when the wastewater comes in contact with that activated carbon sheets that hydroxyl radical will produce from that activated carbon. And again, it is not very selective. You are not very keen about to select. You can select any kind of the chemical which can produce the hydroxyl radical. So it is not very selective process, and it is short lived. Short lived means it is again not require any time. So again, it's very time effective, where it can save a lot of times. So meanwhile, for instance, if an industry generated 20,000 liter wastewater, so you have to start that process on daily basis when you are going to treat that wastewater in such a huge and big industry. So it is again a short lived, so you can start that process again and again, and it is environment friendly, and it is harmless because it does not enter into the environment again. And the next step is the okay. So you people have a clear idea about what is the purpose of producing the reactive oxygen species, because they are very beneficial, very time effective, harmless, and easily generated. So now I'm going to tell you that advanced oxidation processes includes the chemical methods. In chemical, you can use the iron phantom. So the iron phantom is basically a chemical you can use in that process. You just have to took the steps in that protocol, and you just have to mix that chemical into the wastewater, and the result will be in the clean water. And next is the ozonation. In ozonation, the oxygen will be the reactive species, and it can act on that contaminant. The second method is the ultraviolet radiation based method, in which, I have told you guys in the previous class that whenever you can read the bird photo, it means the directly involvement of the light. So basically, ultraviolet radiation, you can have two options. The number one is the photophantom. You are going to use the photocatalysis by including the photophantom. So basically, photocatalysis, what does means this term photocatalysis? It means you are using the catalyst, and you can use the sunlight in it, and it's again very cost effective. You are using the sunlight in treating the wastewater, or in decomposing the contaminants. So again, it is very cost effective, and you can use these processes in practical life. So again is the UV ozone layer. So you can basically combine the two strategies. The number one is the ozone, and the second one is the ultraviolet radiations. Third step is the you can use the electrochemical, you can use the electricity in treating the wastewater. And again, okay, so this is basically a flow sheet, and you people get a clear idea about the advanced oxidation processes. So basically, the advanced oxidation processes include these methods, which I have already discussed in the previous class, but you can have a few things new in this slide. The number one is in chemical, you are going to use the ozonation, peroxidation, and in catalytic activity, you are going to use the Fenton. Again, I have already mentioned that you are going to use the process which is known as photocatalysis, and in electrochemical, you are going to use that anode and cathode type of structure in it. You can use that electrolytic cell in treating the wastewater, and in physical treatment, you can use the ultrasound waves or the microwaves. Okay, in this slide, you can see that emerging pharmaceutical contaminants. So, for example, you are an environmental engineer, and you have to treat the wastewater which has been generated by that pharmaceutical industry. So that reactive oxygen species include oxidation and the hydroxylines. These reactive oxygen species react upon that organic compound. Again, it is biodegradable, short-lived, and environmental benign products. Environmental benign speed, it does not move from one place to another place, so it does not spread the more environmental issues, so it is very environmental friendly. So in this is a very good picture I have found on the internet, that it has a very clear idea that for if you are going to start from the raw sewage, so you can see that in primary treatment in the raw sewage, this is the sewage water that comes from any industrial area or any industry. Okay, the first step is the screening, which is the preliminary stage, and that second in the second step you are going to use the communitors is basically, this is a revolving bodies and it can revolve it is revolving, and the water has been passed into the grid chamber. So here in grid chamber, the basically the grit has been removed from the bottom because the grit is heavy, and here you can use here the phenomenon of gravity has been adopted. So the due to the gravity, the grit basically removed from the bottom, and again the clean water has moved to the next stage, which is the primary clarifiers. So in primary clarifiers, the primary effluent comes into the aeration tank, and here in aeration tank the secondary treatment has been started. So in primary clarifiers, the raw material or the sludge which has been produced has been disposed of from the bottom, and again that the treated water further goes into the aeration tank. So in aeration tank, there is a involvement of the air. So here you can see that there is a round shape air compressor. So that air has been introduced into the aeration chamber, and here in aeration tank, the bacteria, the anaerobic bacteria attacked on that particular contaminant, and the contaminants decompose into the simpler one. And after the aeration tank, the wastewater basically goes into the secondary clarifier. And again, because here we have in the primary clarifier, we term the sludge as a raw or the primary sludge. You can see that it is labeled in the bottom of the pipe, that is primary or the raw sludge. But now we are using the name which is activated sludge, because the sludge has been activated with the help of the microorganisms. So that activated sludge again can be reused for several purposes. So that activated sludge again enter into the sludge treatment, and it can be disposed of from the bottom. You can see the red arrows that it can enter into the sludge treatment. Either there is a need to treat the sludge further before disposing of into the environment or not, that depend upon the objective. All right. And after that secondary clarifier, you can use the disinfectants. You can use disinfectants. So what type of disinfectant you can use, I have already mentioned. Please tell me. So can you please tell me what type of disinfectant we can use at this step? I have already told you that you can use the chlorine in it. You can use the chlorine as a disinfectant agent. So you can use the chlorine, and in that the secondary effluent has been discharged to the surface water. Or if you are going to recycle the water to such extent that recycled water can be used as a drinking water, so you can go for the tertiary treatment if needed. So that the type of the treatment plant or the type of the treatment stage, that where you have to end the process, that entirely depend upon the objective of your higher authorities, or the objective of your industry. So this is a very good flow sheet diagram which I have found out. So this is the real type of the wastewater treatment plants, and in which you can see that the wastewater has been treated. But this is somehow I can say that this is not very effective because it has a direct link with the air. So there will be a, a very unpleasant odor can be spreaded around the local area. So but I just have to show you this because this is one of the wastewater treatment plant. And again, here is another one. Okay, this is the wastewater treatment plant which can be used for the generation of the electricity. So I picked that image from that particular article in which it has been discussed that you guys can see. Yes, you can reuse the wastewater for the generation of the electricity. So electricity is a generation of electricity is a very major issue. So you can use that wastewater for generation of it. So you are playing the dual role. One is you are treating the wastewater, and the second is you are generating the electricity. But again, I would say that it has direct contact with the air, with the environment, and again the problem of the odor and the problem of the unpleasant air can be faced by the residents or by the neighbors as well. So I am going to show you a very interesting wastewater treatment, which can be expensive, but it is very interesting. Here you can see that everything is enclosed into the tanks, into the pipes. So these wastewater treatment are you can say that 100% well suited to the environment and to the society. And I want to say that these wastewater treatment plants has zero discharge because the water has been the wastewater basically passing through a number of the stages. So at the end you have the zero discharge. But again, I want to discuss that thing that if you are an environmental engineer and you are going to suggest that what type of the treatment plants should be installed into the industry, so you have to be very clear about the budget, about the economic condition of your industry, of your government as well. So either the industry can afford such type of advanced wastewater treatment plants or not. So that depend upon the budgets and what. But personally, this is one of the I like the I like this wastewater treatment because it is very well efficient, adopted, and it does not contact with the air, with the atmosphere. And it is there the main product will be the zero discharge water, means that the water can be recycled and it can be transported to the particular area. For example, that the sludge can be transported to the farmers, and the wastewater can be used for the washing purposes. If you are not interested in drinking that treated the wastewater, so then you can use that water for the other purposes, for kitchen gardening as well, for irrigation purpose. So these are the uses. So but again, you have to be very clear about the objectives and about the budget of the uh, company before you are installing such type of wastewater treatment plants. So I have already told you in the previous classes that there is a very novel and innovative technique which is known as the nanoscale technique or the nanotechnology, which have a huge role in the wastewater treatment plants, and it has been working successfully in such type of the treatment plants whose main purpose is to produce the zero discharge water. So the basically the nanomembranes are the nanofibrous membranes have certain types of the nanoparticles impregnated on the surfaces. That the surfaces has been coated with such type of the nano particles. So that nanoparticles comes in contact with that wastewater, and again, on the other side you will have the clean water. So the what is the basic principle behind that nanofiltration membranes? So the basic principle is the adsorption. Adsorption means they can add up those toxic contaminants on the surfaces, and due to its minute size, the surface area increases and the nanomembranes have a chance to treat that water up to the 99%. Okay, the first step is the adsorption, and the second step will be the filtration, and after that you have the treated the waste to have the treated water basically. So basically the carbonaceous nanomembranes you can use in it. Carbonaceous means you can add the activated carbon on the, you can coat the activated carbon on the on that sheet. And the second is the metallic are the non-adsorbent sheets. This, and the second nanomembranes are the metallic type of the adsorbents you can use in that membrane. And the third one is the metallic oxides nanoparticles. So metal oxides basically nanoparticles means doing the process, you are involving the process of the oxidation by using such type of nanoparticles. The third one is the polymeric nanoadsorbents. So basically, the polymeric nanoadsorbents means is that such type of nanoadsorbent which are comes in the form of the polymeric conditions and which comes in the form of the powder form. The third one is the metal oxides framework. As you can see that there is a framework in a circular form having blue and the red molecules in it. So such type of metal oxides has been used in such type of the nanofiltration of the membranes. So you have you ever heard about the concept of the buckyballs? That is basically the uh, buckyball is basically a very arranged structure, and it has the capability to um, to contact with the contaminants, to degrade the contaminants as compared to any other conventional method. So the nanofiltration method is one of the innovated and most upgraded method. So what is the basic principle in it? Like in this picture you can see that here is the water inlet in the form of the blue box. You can say that the settling tank, basically this is the settlement tank in which the process of settling occur. So after the settling there is a pre-filtration unit that you have to filter that water before introduction of the wastewater into the photocatalytic or that type of the nanosheets. So after the pre-filtration units, the wastewater transferred into the that particular chamber in which the photocatalytic filter sheets have been arranged in such a manner that the maximum water comes in contact with that sheet. And after the passing of the wastewater through that sheet, the next step is the carbon nanofiber based filter units. So there is a pre-filtration unit, and after the passing of through the nanofiltration technique, nano membranes are the functionalized with the nano coating. When the water pass through the functionalized nano coating, then again you have the carbon nano fibers based filter unit. That is, you can say that the post filtration. So after the post filtration, the water collected into the water tank, and that treated wastewater can be transported into the several places for the other uses. For example, uh, agriculture. I have already mentioned the agriculture uses, but you can use that wastewater for any other purpose as well. So this is basically the most upgraded and advanced method, which is also the expensive one. But again, I would like to say that whenever you advise such type of wastewater treatment, you must have the budget sheet, that in which budget you are going to introduce the wastewater treatment plant, or you have the design and the space, that what in which area are the in which how many square meters have been provided to you for installation of the wastewater treatment plant. So I would like to say that if you guys have any question regarding these units, feel free to ask. And we have completed that chapter, which is wastewater treatment. So again, I would like to mention that in this chapter we have discussed the stages of the wastewater treatment and the methods of the wastewater treatment. Like stages, we have the preliminary, primary, secondary, and tertiary. And in the methods, like we have the physical, chemical, and biological methods. And again, the next one is this. So if you have any question, please feel free to ask. And I am here to end the today's class.
Oh, ma'am, thank you.
Okay. Thank you, Rosando. Have a great day.
Thank you, ma'am.
Bye bye.
Thank you, ma'am. Bye-bye.